All right, good morning, good afternoon, or good evening. My name is Tyler, and we have another project here within Packet Tracer. This is the first video of a two-part video project series where we will be configuring BGP in the first video, and in the second video, we will build upon the same topology to configure tunneling. So I will give you a little bit of a background about what we have here within our topology at the moment. But first, we do need to identify our objective because without an objective, we won't know what we're doing. If we don't know what we're doing, then we won't be doing anything at all. So let's go ahead and get that objective out the way. Today's objective is to demonstrate how to implement Border Gateway Protocol, that's BGP, across routers, 3 routers to be exact. This project establishes separate autonomous systems, configures eBGP, neighbor relationships, and advertises networks between them. The goal is to show how BGP enables scalable inter-network communication, efficient route exchange, and reliable path selection across multiple networks. So I just want to go ahead and show what we have currently. We do have a topology that features 4 end devices, 2 switches, and 3 routers. Our end devices already have IPs configured to them statically, and we will need to diagram basically our 3 different networks, our 3 different autonomous systems. So to do that, I can go ahead and just grab our ellipse tool. I'll start with our first color. We will do green. Go ahead and draw it here. Let's slide that over a bit. Right, so that's going to be our first autonomous system. We can do our second one now. We'll do the color red. That's, oh, excuse me. Red, select fill. It's a bit orange. And then our last one will be here to the right, our third autonomous system. Let's get one more color. We can do pink. All right. Got it. So we do want to label our different systems. So we can do that now. Let's slide this down just a bit, look a little bit more uniform. So to the left here, this will be autonomous system number 100, because when you are configuring BGP, it does need to be labeled correctly within the router so that we know exactly who we're communicating with. So we'll go ahead and do that now. This will be AS, we'll give it the number 100. Our network to the right can be 200, and up top, without any end devices, that will be 300. Alrighty, so now that we have that labeled, we can begin our configurations. And to do that, we will head into router 1, our very first router. And we do want to label it with a name here within the CLI. So we'll do configure terminal. And then we can do host name R1 for router 1. Now we are in this config mode. To begin the BGP process, we do have to identify our local BGP autonomous system number. So to do that, we'll give it the command route BGP, and then we can do 100 since this is our 100 network. We have now entered our config router mode. And once we're here, what we need to do is identify our neighbor. So let me zoom in just a bit so we can see our neighbor IP here. I can see it, but I want to make sure that you guys can as well. We are directly connected to our router here and the 000 gigabit port. And that IP address for that specific port is 50 50 50 50 with a /30 subnet. So that's what we're going to go ahead and insert in our CLI here. All right, so we can head back into the CLI. for router 1. And the command that we're going to give it is neighbor. And then we do need to detail that IP address. We'll do 50.50.50.50. And we don't need the subnet here. But what we do need to do is identify the autonomous system number here. So to do that, we'll type in remote as 300, since that's autonomous system 300. Once we do that, we do need to give our neighbor information on our network that it now has access to. So we will have to enter our network address here. So for that, it will be network 192.168. What's that? 100.0. And in Cisco, when you're configuring BGP, you do have to add the word mask before we add our subnet mask. So for that, we're going to do mask 255.255.255.0. Since it is a /24 subnet, we can go ahead and hit enter. And so we have it there. And one way to check that is we can do the in command, and then we're going to run a command that is show IP BGP neighbor. Once we run that, you can see right here at the top, our BGP state is active. Now, active does not mean BGP has fully been connected. What we need there is the word established, and that will give us, that will key us that we have officially established our BGP network correctly. So right now we're at active, but we need to get it to established. So before we do that, we'll go ahead and repeat the same steps here on our third router, the same way that we did our first. So we'll do enable, we'll do configure terminal. Let's go ahead and name this router R3, and we're just going to follow the same process. We will do route BGP. This is autonomous system number 200. So we'll give it the number 200, and then we can do our neighbor, and always remember to check our neighbor for this gig port. The IP is here 60, 60, 60, 61. So this is what we'll enter this time instead of what was here connected to gig port 0. So we'll do neighbor, that's 60.60.60.61. And we still do need to name our autonomous system that is corresponding with that IP, and that's 300. So we'll do remote as 300. We also need to identify to our neighbor our network address so that it knows what it has access to. So we can do network 192.168.200.0 with our subnet mask 255.255.255 and 0. And we can go out and check the same way just to make sure we have it configured. We can do the command show IP BGP neighbor. And we also have an active status on this end as well. So how can we get it established so that we understand that BGP is up and running correctly? We do have to head into this router here and just configure our IPs generally the same way, since this autonomous system doesn't have any end devices. We don't have to configure our network. You see, this does not have a network address. It just has the 2 gigabit ports that are connected to our separate routers. So we can head into that router and configure it the same way. So let's go ahead and do that now. We will enter router number 2, enable, configure terminal. And we do need to identify our BGP number, which is 300. So let's do route BGP 300 to create that BGP. And then what we need to do is identify our neighbors. So we can start here with autonomous system 100. We'll do neighbor with the IP address for the gigabit port that is directly connected. So it is gig 001, and this is the IP for it, 50505049 with a 30 subnet, which we don't need to enter. We will just identify that that IP address is coming from autonomous system 100. Let's do that now. 50505049 remote as 100. And there we go. Once we have that in, we can see that we got a message from our CLI that is up. That BGP status is up. Let's go ahead and repeat the same thing for our autonomous system 200 here on the right with the IP that's connected to the port directly connected to our router, which is 60606062. So I'll just go ahead and go up on the keypad. We'll just slide on over and redo our IP address. And be sure to identify it as autonomous system number 200. And there we have it. We have that status is up as well. So now when we head into the routers, we could take a look here and see. We can run that same command, show IP BGP neighbor. And now our BGP state is established. And so it'll show the same thing on this router, and we can check it with my favorite command is that ping command, just to check and see if we have connectivity between the two. So what we're going to try and do is ping our router here. Let's go into this router and just do a show run command. And see if we can ping. You see the BGP is set up here with its neighbor. And we'll go ahead and try and ping that IP, 192.168.200.1. All right. So to check that, we will head into our end device here, and we'll attempt to ping another end device in the opposite autonomous system. Let me correct this IP here. This is 192.168.200.2 with a /24 subnet. Let's just go ahead and double check that here on PC number 2. Head into IP config, and yes, that is the IP. So we're going to start here from PC 0, that is a part of autonomous system 100, and we'll attempt to ping PC 2, which is in that separate autonomous system 200. That's going to be using our protocol BGP. So we'll head here, head to desktop. We'll do command prompt ping 192.168.200.2. And there we have it. We have a reply from our separate network. I do want to go through simulation mode just to give the visual of what that looks like as well. So I'll go ahead and add another ping command. We'll change it to 200.3. And let's bring up simulation mode here. I'll slide me down to the bottom. We'll slide this out a bit. Matter of fact, let's zoom out so we can actually see what's going on. Right. There we go. And let's run that ping command. So run that. Go ahead and hit the play button. And as we can see, that packet travels up to the switch. That packet is going to travel up to the router as well using BGP. It will head to autonomous system 300, which is connected to both autonomous systems through our BGP protocol. It'll head down to router number 3, which will send it down to the switch. And then it will contact the end device so that we can identify exactly which end device we're getting in contact with. So that packet has made it down. It's sending it back up to that switch. We'll fast forward a bit to the router and back to the end device that we sent that ping from. So that was BGP. That was part 1 of this video. I want to thank you guys for joining me in this video. We are going to continue with this same topology for part 2, where we will detail tunneling and show exactly how that works. So looking forward to seeing you guys in that video. Thank you again, and have a good one.